Hello, this is Mr. Waters, and I'm kind of enjoying myself sitting here and writing out these examples for you. So I'm going to do one more. And in this case, we're going to find the equation for the ellipse and we're going to graph it. And here, the information we're going to be given is this. We're going to be given that the focal points are at 1, 2 and at -3, 2. Okay, we know where the two focal points are, and we're going to be given one of the vertice points, one of the vertex points, which is going to be at -4, 2. Now, that's only one of the vertexes. There's 3 other ones, and we don't even know if that's the major axis vertex or the minor axis vertex. So what we have to do is we're going to have to draw a little sketch and analyze this shape a little bit. And then eventually we're going to end up with an equation. So, and we don't even know if it's a vertically or horizontally oriented ellipse. That's something that will have to come out in our analysis. So let's make a little sketch here of the graph, and we're going to have to graph it anyway. So let's go ahead and start with what we got. Okay, and let me see now. The focal points are at 1, 2, right there, and at -3, 2. Well, notice that those two focal points are oriented along a horizontal line. The focal points in an ellipse are always on the major axis, so that tells us that, oh yes, the major axis has to be horizontally oriented, so this is going to be a horizontally oriented ellipse. So that means the equation the equation form for our ellipse is going to be something like this: x minus h quantity squared over a squared, y minus k quantity squared over b squared is equal to 1, and the a squared, the major axis value, is under the x squared for the horizontally oriented ellipse. Now, what we have to calculate is we have to calculate the center point, and we want to find the rest of the vertices. We have one. Okay, well, the center point has to be halfway between the two foci. So our foci are 1, 2, 3, 4 units apart, right? So that's 4 units apart. So that must mean the vertex. Now I'm going to remove that so that it's not so confusing looking on our drawing. That means that our center point has to be halfway between them, 2 units to either side. So that means that our center point is going to have a coordinates of left 1, up 2, so it's going to be -1, 2 are the coordinates of our center point. Okay? Now, that's not really part of what our answer is going to be, but it's something we need to kind of help figure. We need that to help us figure out the equation. Okay, so the vertex point is at -4, 2. So let's put that in. Okay, 1, 2, 3, 4 to the left, up 2. So there is our vertex point. Now, since it is a horizontally oriented ellipse, that looks like that's going to be a horizontal. That looks like that's going to be our major axis vertex point. Now let's look at the information that this sketch gives us. Here's the center, and we can see here that from center out to the focal points are 2 units. So we can see here that C, the focal distance, is 2. And if the center point here is at -1, 2, we can see that it's 1, 2, 3 units to the vertex point. That's the major axis distance, so we can see that A must be equal to 3. Okay? So what do we get from that? So that gives us that C squared is equal to 4, and that A squared is equal to 9, which is going to give us one of our values for our equation. Now we can use those to get B and B squared, because C squared, our handy-dandy equation, C squared equals A squared minus B squared. So That's 4 is equal to 9 minus b squared. And wow, this has come out a lot in our examples, but that gives us, I think you can see that b squared is going to be equal to 5, and that b is equal to plus and minus rad 5. We get plus and minus because there's two minor axis vertices, one above the center and one below the center. So that means, so for the purposes of our equation, we're going to use a b squared of 5. Now I guess right now we can finish right on our equation because we have the center point, which is negative 1, 2. We've got the a value, which is center, which is negative 1, 2. We've got the a squared value, which is 9. We've got the b squared value, which is 5. So our equation is going to be x plus 1, x minus negative 1 over 9 plus y minus 2 quantity squared over 4 equals to 1. And that is the equation. Now we're almost done with the picture too, with the graph. Let me kind of neaten this up a little bit so that we can see what's going on here better. Okay. And so now to get the minor axis vertex points, we're going to start at the center and count up rad 5 and down rad 5. Rad 5 is about 1.7. So I'm going to start from here at negative 1, 2, which is center. I'm going to go up rad 5. I'm going to go down rad 5. To get the vertex point on the right side, we're going to count 1, 2, 3. So there's our other vertex. And here I guess we can go ahead and draw our ellipse in like that. So this, you can see this vertex point is now negative 1 or negative 2, positive 2, 2. This one we were given was negative 4, 2. This vertex point here is, since we counted up from the y value, is negative 1, 2 plus rad 5. And this value, since we counted down from the center, is going to be negative 1, comma 2 minus rad 5. And those are our center points. That's the vertex point. The focal points we've got, and the center point is negative 1, 2. And then this point here is going to be negative 3, 2. And this point here is going to be 1, comma 2. And there is our graph of our ellipse, fully labeled, all of the critical points labeled. Here is our equation, and we are done. Thanks for listening.